Hey math kids, we're going to do more coordinate geometry. This is part 3 of this video. So we're given a circle with center -2, 3. And we need to determine whether -4, -1, and 3, 5 are on the same circle. So we basically just need to write the equations. Well, let's write the equation of this circle. So x plus 2 squared plus y minus 3 squared equals radius squared. So we don't know what the radius is. These will help us determine the radius. So what we're going to do is just plug in these points, and that will help us find the radius for each situation. If we have the same radius, then it's on the same circle. If it's different radius, different circle. So let's just do -4 plus 2, -1 minus 3 squared. And for that, we get 2 squared plus -4 squared. So that's 4 plus 16. So that's 20. So r squared equals 20. We don't have to take it all the way to the radius. Okay, now if I plug this one in, we get we get 3 plus 2. Once again, I'm plugging it in up here. 5 minus 3 equals r squared. So that's going to be 5 squared plus 2 squared. So that's 25 plus 4, so that's 29 equals r squared. Since these are not the same, they're not on the same circle. So that's all we had to do on that one. Okay, the next one says there's a triangle with vertices 4, 3, 8, 6, and 8, 3. We want to know if it's a right triangle. So maybe drawing this one out would help. So 1, 2, 3, 4, 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8. And 3, 4, 5, 6. And then 8, 3. Alright. So the way that we can determine if it's a right triangle, so if I'm looking at this, my guess is this is the right angle if it's a right angle. And so we just need to find the slope between these two. So this is 4, 3. This one was 8, 3. And this one is 8, 6. Okay. One thing to point out, because these share a y and these share an x, my guess is it is perpendicular. It should be. But let's double check with slopes. So the slope of this line is change in y's. So this is going to be, goes up 0 and over 4. So that's a slope of 0. And then this one, the rise is 3. The run is 0. So that's undefined. So this is horizontal, vertical. So that is a 90-degree angle. So this is a right triangle. Okay, and the last one, so if we have quadrilateral FREG, where we're given these coordinates, we want to know, is this a rectangle? So basically we just need to prove that all of the, we can prove it a couple different ways, but I would just do the angles. So if it has 4 right angles, then it's a rectangle. So -3, 0. R is 1, 3. G is 3, negative 2. And then G is 0, negative 4. Okay, so if we connect this on this diagram, it looks like it could be. So let's just do slopes. So if we're from here, we go 0 to 3, and so that's a 2. Or, no, we don't. That's a 3. To go from 0 to 3 is 3, so the rise is 3. And then the run is from negative 3 to 1, so that's a run of 4. Okay, we do this one, and we do 3 to negative 2, so it's going to be negative 5. And then 1 to 3 is going to be 2. So right now, we know that it's not a rectangle because if we have a 3, 4, the opposite reciprocal would be this. So it would have to be negative 4/3 in order for this to be a right angle. Since this is not a right angle, it can't be a rectangle. Now, if it was a right angle, we'd still have to test the other ones, but since we got lucky and found at least one of them that wasn't, we can move on. If you need additional help, come to Math Lab. Until then, calculator.